Hello, this is our part 1 of 2 of the Unit 1 review for the exam that's coming up on Unit 1. Just wanted to make mention of a couple of tools that you have here before we get going into the review too far. So let's say you start going through the review and you get to something like, 1 through 4, and you're like, yeah, those fractions that are there kind of give me some trouble and stuff like that. What you've also been given with the review is an exam checklist. And basically it tells you what sections are in there and what things you'd need to know in there. For instance, in 1.3, solve an equation with fraction coefficients. We've got here number 4. What that's going to do is it's going to allow you to know where in your notes to look, or if you go to Mr. H's YouTube page, what section to type in. You can even type in the title, and that might even help you. But even if you just type in 1.3 in the search, it'd be there, or look around on the website. So you have some options available, and it also gives you kind of a checklist. Do I know how to do this? Yep. Do I know how to do this? Yep. But these are basically going to be the same order they are in the review. So I'm not going to sit in class and tell you every single section to look for in the review. You're going to have to put some work in that way. Okay, end of 1 minute mini speech. I will get this checklist out of the way. Also available on the website if you need it. But let's get down to business. So we start taking a peek here, and we're like, all right, up at the top, equations. Most of you are equation experts. This isn't going to be a real bad spot. So we'll just kind of jump right in. So we'll go ahead, we'll distribute here on the left. Make sure you distribute to both terms. And it's in your best interest to go ahead and show all work. Well, why? Because I give partial credit on things. So if you get a couple of steps in and everything's going good, and then all of a sudden you do something silly, like add instead of subtract or something like that, you still can get some points for things. If you just go to an answer and it's wrong, well, it kind of screws you over. So just keep reminding yourself on equations. I'm going to do opposites. And divide at the end. So I won't talk a whole lot when we're getting to some of these early ones because, well, we've got this. At least I think we do. So I get to number 2, same idea. Make sure you take the negative with you, and negative negative times negative is positive. Over here, a little simpler, no sign changes. I'm going to add my 7x to both sides. Get that set. Minus my 20 back over. Now here is a moment of truth for some of you, and hopefully it's not where you're going to lose like a point on something silly. My last step here is to divide by 12. And some of you see 12 and 6, and I'm not going to say, it's 2. No. The larger value is down below, which means I'm going to get a fraction. And if I reduce the fraction via either math enter enter, or knowing that each of these are divisible by 6, I get 1/2. So don't lose a point there just by being a little bit silly. Another hint, I like to fill up the reviews with hints so you can help yourself out. I like to put parentheses when I see the plus or minus. Well, why is that? Because then when I actually go to do the problem, I remember, that negative 2 multiplies to both the x and the 6. The 3 multiplies to both the x and the negative 4. So I'll distribute through. Watch those signs. So I go to get all my x's together. So I'm going to add 2x to get my x over there. So that'll give me 5. Then since I'm trying to get this alone, I'll add the 12 back over here. And here's another moment of truth. Some of you will get here and you'll be like, it's 0, it's no solution. No. If I go ahead and divide by 5, 0 divided by 5 is still 0. The only time it's undefined is if I'm dividing by 0. So you can get 0 for an answer, and that's absolutely okay. We've chatted before, time and time again, on problems like number 4, on finding the least common multiple, least common denominator. And I can do it one of 2 ways. We've talked about the ability, if I need to, via mentally or via a little off to the side, that I can either list the numbers and start counting until I find the same number in all 3 lists, and use that number to multiply through. That's going to be the smallest number. It's going to be the smallest values to work with, which is cool. That's one way. Or again, we've talked about how you can multiply the different numbers below, so I don't have to use the 4 twice. Multiply them and use that number. And for a lot of you, that seems to have been working lately. So that's what I'm going to do here. So 4 times 6 is 24, times 2 is 48. Would it still work if I multiplied by the 4 too? It would, but I don't like numbers that are that big. So if I use the 48, we've talked about this before. Multiply times the top number, divide by the bottom. You have to do both. So 48 times 1 is 48, divided by 4 is 12. 48 times 5 is 240, divided by 4 is 60. 48 times 5, let's see, is 240, divided by 6 is 40. And 48 times 3 is 144, divided by 2 is 72. So at this point, now it's just a regular equation. I got rid of all the fractions just by multiplying by the top and then dividing by the bottom. Oh, let's see. Let's minus the 12x. I like to keep my x's positive. I try to be a positive person in general. And again, don't freak out if it doesn't come out nice. You're like, yeah, I don't know what this is. Okay, well, let's let the calculator help us. So let's see. We're looking for negative 132 divided by 28. Yeah, I don't think this is going in nice. No. Well, but I don't like that decimal, so let's do some math, enter. All right. Oops, get that in the screen here. Okay, so it's not bad to go to your calculator, but again, just about every calculator has some sort of a fraction button on it, so I really do want you to get it into at least a fractional form for me, okay? Oh, then comes our arch nemesis again for some of you in 5 through 7, the dreaded solve the formula problem. Now again, solving the formula is still within those first couple of sections. This would be in 1.4. So if this is your bad place, there's the place to find the help. But just keep reminding yourself, these are like regular equations. Okay, solve for b. Okay, what's being done to b right now? I'm multiplying it by a. Well, I need to do the opposite if I want to get it alone. So I do the opposite, I divide. And I'm good. And sometimes it can be just that simple. Now, will it always be? Well, no. Okay, like for instance here, I'm trying to solve for a. Well, first I got to get this alone. Oh, I got to undo that fraction. Okay. So we're going to multiply both sides by 2y. Now again, that wipes out the 2y on the side. It doesn't distribute through. And this looks so weird that you're like, yeah, this can't be right, but it is. Okay. One step, got rid of the fraction. Now my job's to get the 3a alone, but I'm adding 4 to it. So I got to do the opposite to tell it to go away. Okay, this 4 doesn't have y and m. They can hang out on the same side, but they can't be combined. And now I've only got one step left. Since I'm multiplying a by 3, I'm just going to divide, and that's what I have left. For our final one, and you knew this was coming, I think now I went back and counted. This is the 9th time we've done a problem like this together. So I think at this point, I think we got to be getting the idea. Solve for r. Wait a minute, there's 2 of them. What do I have to do? Let's see. Maybe there's a hint over here. Isolate a variable, and you have to factor out the common variable distributive property backwards. Oh. What do they have in common? They have a common in r. Okay. So if it's the distributive property backwards, what do I multiply the r by to get to r? This is not a trick question. 1. 1 1 times r is r. What do I multiply r by to get ART? Well, I already got the r. I need the AT. And notice what happens. And hopefully you're paying attention and writing at this point. I only have 1 r now. And that's what I'm trying to solve for. So my job now becomes, okay, what am I doing to r? I'm multiplying it by 1 plus AT. What's the opposite of multiply? Divide. These aren't bad problems. You just got to get in there and get after it. That's the only way anything gets better for the most part, anywhere in life, math, anywhere else. You've got to keep trying stuff till you find something that works. If it doesn't work right away, you got to keep trying. I'm learning that out firsthand now. So that takes care of our equations. Choose the inequality that describes the graph. Okay, what do I notice? I notice it's a bracket. So I notice I'm going to need a bracket with my answer. So it's not B, it's not D, because they don't have brackets. Okay, which way is my arrow going? My arrow's going to the right. Which way is that towards? Positive infinity. That is negative infinity. Boom. Use the clues that are there to help you. Number 9. We're at the fair. And all of a sudden, we're going to be paying $5 for admission and $1.50 for each ride. So write an equation that describes the relationship between the rides, R, and the admission, A, in dollars. Okay, so if I think about it, and I don't have to write it out in words, but it might help. So my admission plus my rides equals the total amount of money I'm going to spend. So I'm like, okay, so let's see. I pay $5 for admission, and no matter what, I'm going to pay that, so I don't need a variable. My rides, I pay $1.50 per ride. I'll just use T here. You could use anything. You could use X or something like that, but that's all I'm going to do. Now, some of you may say, well, if I had to put A with admission, would that be wrong? Not necessarily, because maybe you're doing it for several people. Okay, that would be all right too, but this would be just fine. And then continuing on our trek through section 1.5, Mr. H is planning a party for 50 people. He has $245 to spend. A $50 meat tray feeds 12 people, and a $35 cheese tray feeds 8 people. So what are the things that we're working with here? Well, it looks like we're working with C for the number. Gotta have that. Number of cheese trays. M is my number of meat trays. Now, one thing I notice when I'm looking at this is I'm like, okay, what information do I have? Well, let's do all the information that has to do with money first. Okay, so I got $50 for every meat tray, and I got $35 for every cheese tray, and I spent $245. So then I look at the other part. I'm like, okay, well, what else do I know? Well, I'm looking for 50 people total. So let's check out the people part of this. Meat trays feed 12 people. So 12 people per meat tray. And a cheese tray feeds 8. 8 people per cheese tray. And I have my system. Okay. So I may have to dig in a little bit and look for the things that go together to make sense of this and make my equations. So all right, page 1 survived. We're through 1.3, 1.4, and 1.5. Good job. We're going to do the back of this sheet, and then the rest will be for part 2. All right, Algebra 2 F word. Now, reminders with the Algebra 2 F word. We need to always, very first, okay, now here's our breakdown sheet that we've been using to kind of get our heads thinking about this a little bit. And again, when we hit the test, I don't even care if you use this during the test. It's okay. But when you're looking at this, number 1, underlined, starred, the golden rule. Is there anything in common to factor out? That's always what you have to do first. Because if you don't and there was, it's going to be wrong. So I look and I go, okay, what do they have that could be in common? 7 and 21. Wait a minute. 7 divides into both of those. And I'd say, yes. And you'd say, wait, there's more. X squared, they both have an X. Ooh, now we're rolling. Once I've factored whatever's out, I put a set of parentheses, and again, we're doing the distributive property backwards. 7 times what gets me to 21? Write that down. If I have 1x and I need to get to 2x, I need another x. And then 7x times what is 7x? You can't say nothing because that would give me literally nothing. Anything times 1 gets me that back. There's no squareds left. I'm done. So then I look at the next one. I'm like, okay, x squared. They don't all have x. 6 and 4, oh, it doesn't have a number. Okay, they don't have anything in common. Now what do I do? Let's see here. No number in front of x squared. Yes. Use the diamond. Okay. Reminder on the diamond. If you like writing the diamond, write it out. Otherwise, just remember, it's the number on the end we multiply to. It's the number in the middle that we're trying to add to get. And don't tell me you're not good at multiplication. Then you have to work at it. Or you have to use the calculator and divide numbers in. So for instance, if you look at this and you don't notice right away that your values would be 10 and 4, and the 10's negative because I'm adding to a negative, you may have to go to the calculator and literally start trying to divide numbers in until you find a pair, looking at these, that works. 10 and 4 can get me to 6. Okay, that's the only other option right now. There's no other shortcut. We're not doing charts in here. We're juniors in high school. We've got to get this down. Well, some of you are sophomores and seniors too, so no offense. So, once I have these two values, negative 10, positive 4, I'm done. Okay, so if there's no number in front of x squared, that works. You're like, okay. Next one, 25 and 36. Okay, nothing goes into 25 and 36. Let's see here. Are they perfect squares? Oh, yeah. All right. Perfect squares. Got to know my squares. We've talked about that. Got to know them up to 10. Got to be able to look at this and see perfect squares. 5 times 5, perfect square, 25. 6 times 6, 36, perfect squares. Since I'm multiplying to negative 36, it's got to be one of each. It cannot be two negatives. That will not work. We've looked at how that foils out. It doesn't work. So that's it. I'm done. We should like those. Should. But I don't know. Some of you do, some of you don't. All right. So then we get to factoring. Now again, some of you do it with the mental math. Some of you are doing it with slide and divide. All depends on how you go about this. Some of you are like, well, how's the mental thing go again? Because I've been doing slide and divide, but I don't like how long it takes. Okay. If I'm going to go mental math, here's what I have to do. I look at the first number. I say, okay, what can I multiply to get 2? 1 and 2. That's my only choice. Okay. That's nice. Probably should use a pencil for this. I got to watch it here. So now, it's not like a diamond. I'm not trying to multiply to 7 and add to 13. That doesn't work. I do want to find two numbers that multiply to negative 7. You're like, okay, well, it's a negative and a positive. So 7 and 1. Okay. So let's say I put in 7 and 1. And I know it's one of each sign, so I don't know, negative, positive. I got to see if my O and my I get me this. So I look and I'm like, negative 7 plus 2. That's not negative 13. Okay. So I look and I say, okay, I'm doing mental math, so I'm just going to switch these. Positive 14, negative 1. Oh, that's positive 13, but I need negative. Okay, I can fix that. I'm just going to change the signs. Negative 14, positive 1. Bingo. I'm done. If you're comfortable playing around like that, if you kind of, when you're trying to learn something new, you just kind of play around with it instead of reading the instruction manual, maybe this is your way to go. If that's not your way to go, if you're like, I want something straightforward, I like the diamonds, is there a way I can make this happen? Yes. And here's how you make it happen. You're going to take that 6. We're going to slide it down to the end. In other words, we're going to multiply it down there. So I get x squared minus 7x, minus 120. Harty, what are you doing to me? Okay, this is one of the issues that comes with this. So like I did up before, I may have to play with the calculator a little bit. I may have to go, okay, 120 divided by 2, start small, is 60. Those aren't 7 apart. That's not going to work. And I'm going to start just dividing. Okay, I need a bigger number. Let's get to 30. 30 and 4. I'm still not getting to 7. It's got to be bigger. Okay, let's try 6. That's 20. 6 and 24. I'm getting closer, though. It's 15. 15 and 8 to 7. Okay, I think this is going to work. Let's play with this. So 15 and 8. Now, how do I figure out which one's negative and which one's positive? Because it multiplies to a negative. I know that's going to be the case. They add to a negative, which means the negative's got to be the bigger number. Now, before you circle that and say, woo, I'm done, and then get points off on the test, oh yeah, the name of this thing is slide and divide. I haven't divided yet. So I've got to divide these. Now, here's the kicker. No, they don't go in nice. You know, you check it in your calculator, check it in your head. But I can't just swing the 6 back to the front, because if I do, it's not going to FOIL out right. Remember, you've got to reduce the fractions with this if you're going to use this method. So whether you do that in your head, that'd be cool, or instead you go, okay, so 8 divided by 6, and whatever your fraction button is in your calculator, for the ones in here, it's math, enter. So that's going to be x plus 4 over 3. I'll do the same thing with the 15. 15 divided by 6, math, enter. Don't lose the sign, minus 5 halves. Not quite there, almost. Last part. Take that number, since they didn't come out nice, swing it back to the front. 3x plus 4. 2x minus 5, and I've got it. Okay, there are no shortcuts to knowing multiplication facts, working these out, or you've got to kind of play with them to the side like I did. Can it get frustrating if the numbers get kind of big? Sure, but it's still not something I can give up on. Okay? So now the last one, there is a shortcut though. Why is there a shortcut? There's not a number that divides into all of them, because I did the golden rule first. They all don't have x, so what do you mean there's a shortcut? I could do slide and divide on this. I'm not going to on this problem, though, and here's why. Look at the first number. Look at the last number. They're both perfect squares. Oh my gosh, you're telling me again I need to know my squares? Yes, and I'm even going to give you a sheet so you can have an idea on what they are. So if I see both as perfect squares, how does that help me? Well, what do I square to get 4? Well, 2. What do I square to get 49? 7. And then just look at the sign of your middle term. Square it. I'm done. Now that is much better than going through all of this. But I have to work with these to recognize that. And if factoring is, if that's getting you with stuff right now, again, all this stuff up here, okay, 5.2, we've done notes, we've done half sheets, we've done videos. You've got to pound away at this if you want to be successful. And this doesn't go away. So don't think it's going to. Just saying. All right, a few problems left today, and then we're going to hold off on the rest of these, at least on video form, until tomorrow. No, it's not time to go. Okay. For the expression x squared plus bx plus 6, is there just one value for b? Justify your answer to the example. You're like, well, how do I know what numbers are in the middle? Here's the real question. many pairs of numbers multiply to 6? Is there only one choice? No, not in this case. Okay, how many different pairs of numbers are there to multiply to 6? Well, let's see. There's 6 and 1. There's 3 and 2. Oh, there's -6 and -1. There's -3 and -2. So what does that mean? Here's what that means. If I did a pair of parentheses, let's say, with x plus 6, x plus 1, and I FOIL that out, I'd get x squared plus 1x plus 6 is 7x plus 6. So my b value would be 7. But if I use a different pair, any pair, and you don't have to show all of them, just an extra one to show an example, what if I did x plus 3, x plus 2? Okay, we'll FOIL that out. X squared, outer is 2x, inner is 3x, and I'll actually show this one out in a second. Okay. But I just proved there's more than just one b value, number that could be in front of x. And all we did was we FOILed this out. And there's where my 5x was coming from. It's the same way I got the 7. But that's how you can show an example. Think of some different pairs of numbers, and then just plug those into parentheses. FOIL it out. Show me what's going on. Anytime there's more than one pair of numbers that can multiply, you're going to have more than one value for v. But that's how you can explain it. State the domain and range and determine whether it's a function. Reminders, domain, x values, left to right. No arrows, no infinity. Let me say that again. No arrows, no infinity. Now if there are arrows, they're going to be infinity. So where's the leftmost x value on my graph? -7. Where's the furthest most right point on my x values? 6. Range, same idea, except it's y values. And now it's bottom to top. Y values. Bottom, -1, because again it's y's. Don't use this. To top, 8. And since there's no funky business going on here, no curves or anything like that, it's our vertical line test. We're looking to see if it's a function, and it never goes through my graph at more than one place. I need to stop doing these during my prep when these bells keep going off. So yes, this one's a function. Now, you've had one there, now you get to draw one, and we did one like this on the last quiz preview and have talked about it before. Draw a function that has a domain of -infinity to infinity. As soon as I see that, we're getting an absolute value function. We're getting a v of some sort. Here's how I figure out what type though. In a range of the bottom -infinity, so it's going to be going down forever, up to 4. So it only goes up as high as 4, but then it goes down and left forever, down and right forever. Domain, forever left, forever right. See, there's where the arrows come in with infinities. And then my range starts at the bottom at -infinity and comes up to the top. So just keep reminding yourself, -infinity, infinity, it's a v. If those were switched around, like 4 to infinity, it would just open up because 4 would be the bottom of my graph. It's just letting you apply some of this stuff. You have to think a little bit. And then our last couple for this part 1, and we'll do part 2 a little later. Describe how the graph of the function is related to the graph of h of x. Notice a lot like our last quiz preview. Okay, related. The question being here is, what are the shifts? How does the graph move? And we've talked about this before, but I'm happy to put it down here again. It's all based on my initial formula for these. And we've talked before about how the value that's in here, my h, tells me if I'm moving to the left or the right. But again, it's the opposite because of the minus. So if I see a plus in there, I'm moving left. If I see a minus, I'm moving right. And then for my k, that tells me if I'm moving up or down. But it's a plus, so it is what I actually think it would be. And the only other thing I need to remember is if my a is negative, it flips. It flips my equation. It makes my graph go downward. Okay, and I've even said you can draw a picture. That's okay. So I look at this and I say, okay, plus 3. Okay, it's inside, it's plus, okay, that's left. So left, 3. That's the only shift. That's the only relation that's going on here. Here, it's outside the absolute value. Minus is down. Down 6. And I know you're saying, you make all these cute little things, but I can't use them on the test. Right. But if you practice with them, you will have success. If you need more practice, go back to 2.8 with what we were doing with the homework. Do a problem out of the book. Go back and look at a worksheet and try a problem with it. Those are the things that we're going to try and do to help ourselves improve. We'll look at the rest of this next time. But for now, keep working with these. When you get stuck, find it on your exam checklist here. Work it out that way. When all else fails, see me and work with the videos some. We'll catch you later.